There is nobody in this room that has said as many or as nice a things about me personally than Don at Puppy. And he has worked really hard, not just for me, but for all of women and minorities. And I want you all to look around the room right now and notice how many women and minorities are in this room. Because you will not find that anywhere else in any tech event here in Seattle. And a lot of that is thanks to Don. Continue to live up to your expectations for diversity and inclusiveness. Second thing, about 4 years ago or so, I gave a talk here at Puppy back when we were young, and it was not an advanced talk. It was about a game engine, Panda 3D, which is written in C++ and Python. And a couple months after that, I went to an interview, and the first thing that happened was one of the people who was interviewing me said, "I saw your talk at Puppy, it was really good. Thank you." And I can tell you, that interview went better than any other interview, right? And you can say, yes, I got lucky, and I did get lucky. However, if I didn't give the talk, it definitely wouldn't have happened. So I encourage you to increase your odds of good things happening by getting out there, giving talks, going to programming nights, and meeting people. And the last thing is, I apologize to anybody who saw this talk in Pi Cascades. I have recycled a couple of the jokes. Okay, but not the first one. Hey. So this is an ENIAC computer. It's one of the very first general use computers, and it was programmed primarily by women. And I read an article in the New York Times Magazine a while back that talked about these women, and I want to read a quote for you right now. It says, "The ENIAC women were among the first coders to discover that software never works right the first time, and that a programmer's main work, really, is to find and fix the bugs." And this is why we're listening to my talk right now. And I would point out that when guys started software developer work, it didn't change. It still never works right the first time. So we're going to talk about hunting bugs. I'm going to start off with a little scenario. We'll talk about the stack, talk about the debugger, and some strategies. So imagine that you are receiving bug reports. You get a bug report from a customer that something, maybe your web API is not working the way it's expected. So you go and you look at your logs to try and figure out what's going on. So before I continue, I want a show of hands for how many people have gone to their logs to find out what's going on, only to discover that the logs are either not there, or they're saying the wrong thing, they're not logging the right thing. Show of hands? Okay, for the 2 or 3 people that did not raise your hands, it was a public service announcement that you need to check on your logs and make sure that they are where you think they are and they're doing what you think they should be doing. They have legs, I don't know. Okay, so you've looked at the logs, or you've gone and you've redone the customer's call, and you verify that yes, indeed, they have found a bug, and now you need to try to find the bug. But I want you to stop and not succumb to that immediate urge to go and change stuff and figure out what's going on. And the reason for doing that is because you really need to write an integration test that fails before you go anywhere. And you might ask, why is this important? How many people have been working on fixing a bug, ran some tests, and had an entirely different, something you didn't think would possibly fail anyway on their test? Right. So when you go, bugs repeat themselves, they just come back over and over and over again. And if you have a test that checks for a bug, you will catch it much, much, much more quickly than if you don't. So it's important to have tests that are checking for those bugs that crop up. And you might say, well, I can just write the test afterwards, right? The problem is, well, we can do another survey. How many people have checked, let's see, written a test that they expected to pass and had it fail, or written a test that they expected to fail and have it pass? Yeah. And there are many reasons for this, but one of the reasons is the test can be very hard to read. It can be very hard to tell what they're actually testing. It might be because you're using a framework, a web framework. It might be because you're doing mocking. For various reasons, sometimes tests are really hard to read, and it's easy to write a test that's not testing exactly what you think it's testing. So if you write it afterwards, you might write a test that passed, and it is not testing your bug that you think you may have fixed. So it's best to test before. Okay, we're going to take a little diversion now to the stack, a little review of the stack. The stack is a list of the things you've started but not finished. So if we're making a cake in the previous slide, maybe we're in the middle of the add flour step. The add flour step is part of the make batter step, which is part of the make cake step. Now I went from the bottom up on purpose because in Python, that is the best way to read the stack, because the bottom is the most recent call. And it's always a part, it goes more general as you go up. Now you notice what's not here, right? We do not have anything about greasing the pan in this list. And that's because greasing the pan already happened. It's done. And once something's done, it's not on the stack anymore. Same thing with frosting the cake. We haven't gotten to that step yet. It's only the things that you're in the middle of. This is a great website for playing around with the stack. Even if you understand the stack, it's fun to go and play around to see exactly how things go in and out. So a stack trace. A stack trace is just the stack with some extra information. So it's the stack when something goes wrong. So at the very bottom is what went wrong. And then if you notice, there's add flour, make batter, and make cake, the same as there was before. And now we just have some extra information about where to find those things. So this is the stack, just the stack. And again, you start at the bottom of the stack trace. The problem, the exception, is always at the bottom. And then often, that next line up is the part in the code where the exception happened. So here's a simple stack trace. And we can look at the bottom and we say name error, name below is not defined. We go up one line, we see print hello. That seems likely that we've forgotten to put something into a string. And if we go and look at that code, we see, oh yes, that's what happened. Notice that the stack trace here is bigger than the code that caused it. This is common and nothing to be afraid of. The stack can get really, really, really big, but it doesn't mean that it's necessarily going to be hard to troubleshoot. So to show you this, let me just add something to the stack. All we have to do is call another function, right? All this function does is call the other function. And now we have extra stuff in our stack. But it hasn't changed anything. Sometimes, however, an error only becomes apparent during the line executed on the bottom. If we think back to our cake, when we made our cake, let's say we added some baking powder that had gone bad, right? If you look at the batter, you can't tell that there's anything wrong. Everything looks great, right up until you pull it out of the oven, right? So now is where it becomes obvious that the problem happened long ago. This happens in code as well. So you might have this type error at the bottom, where you have an unsupported operand type for division. And if we look right above it, we see return num over 10, doesn't appear to be in this part of the code. So if we go back to the stack, we look up one more line. We see that in line 9, that's where we're actually calling this function that we just looked at. So let's look at that. So at line 9, we have this print divide by 10. If we go right up above that, that's what happened just previous. And that's what we call bad function. And if we look up at bad function, we see, yeah, bad function is doing something super silly. And the problem was in bad function. But if you look back here at the stack, this bad function is not in that stack. It's nowhere in that stack. But we were able to go and figure out what it was by using the stack. We looked one up and we saw, okay, what happened right before that? And we could figure it out. What about this stack trace? This one got a little crazy. Sorry, it doesn't really fit. So in Python 3, they've started to give us all of the stack trace. So if there are stack traces upon stack traces upon stack traces, you get them all. It's lots of fun. It's better, honestly, but it can lead to giant stack traces. And in this case, sometimes the problem that you care about is in the last one, but sometimes it's not. So you want to look at all of the errors and where they're coming from to decide if you're handling the error correctly. So the reason that this happens is because you made a mistake, you tried to handle the mistake, and you made another mistake. Right? So if we look at the code that caused this, we see that we failed to print because reading was a number. And then we tried to catch that exception, and we tried to do something about it. We tried to print something, but we made the same mistake again, where now we're still trying to combine a number and a string. And it's not clear exactly how you want to solve this, because this is super silly. But you want to pay attention to how you're handling errors in addition to how you're writing your code. Because it's very annoying to have the stack trace upon stack trace upon stack trace. So you should keep your exceptions as tight as possible. Okay, I'll just talk about the stack trace, but remember, going back to our scenario, we had a failing test. We didn't actually have a stack trace. So let's talk about that. Betty Snyder realized that if you wanted to debug a program that wasn't running correctly, it would help to have a breakpoint, a moment when you could stop a program midway through its run. To this day, breakpoints are a key part of the debugging process. Thank you, Betty. Debuggers make our life easier. In Python, it's the PDB, Python debugger. And you might say, but print works. And it does. I've used it. I still use it. But it does have some drawbacks. If you're making network calls, if you're calling a database, if your call just takes a long time, you never write the print statement in the right place. You're never printing out the right thing on the first try. And every time you try and figure out what should I be printing, you're running that same call over and over and over again. You often forget what you're printing, forget to put the variable name, forget where the print statement is, and then you have to go hunt for it. And one of the crucial bits is that if you're looking at code, you cannot tell how you got to a particular function just by looking at it or just by print statements. Right? You look at this function and you say, okay, it must have happened earlier. What was I doing before this? You can't tell just by looking at the code. So W is part of PDB, and it's very helpful, and you've seen it before. If you look at W up above and this traceback, they're pretty much exactly the same. So there's a little syntactic differences about line numbers and file names, but it is the same thing. And if you can read a stack trace, you can read W in the PDB. So if you can put a breakpoint in where you believe a test should pass through, so your code where you think it's going to pass through, then you can stop and you can look at this, look at your stack and see what's going on. And then you run your test. And you stop at the breakpoint, you check things, you look to see, you can go up the stack, you can look at different things, you can look at your variables. But every once in a while, it just goes whoosh, and it doesn't stop at the breakpoint at all. And you're like, what happened? Where did it go? And this is really, really frustrating. It doesn't happen that often, but when it does, it's pretty annoying. So I have a little bit of a technique for getting to it. So generally speaking, when you have code, you have lots and lots of different pathways through your code, and you want to test all those different pathways. And so if you have one where I think it should be going through here, but it's not, you can try a similar test, something that's supposed to be testing the same thing, and say, okay, does this one stop at that breakpoint? And if it does, you can look at that stack and say, okay, where else should it have stopped? Is it stopping earlier? And you can go back and forth between the two tests. And here's an example of just a stack trace where you would say, okay, I'm going to check the print divide by 10. That didn't stop there. So now I see this test also went to add to stack. I'll put a breakpoint there. Does my new test stop there? Keep going up the stack. If you get to the very top of the stack and you haven't hit it, they probably just spelled your app name wrong. So use the stack, go back and forth between the tests to try and track down where it should be hitting and where it's not hitting. When you're looking for tests that are similar, think about the pathway. So an example I like to give is if a REST API, for example, is getting soccer statistics for a team, and for some reason the goalie is always failing. Every time you try and do that REST API, the goalie's failing. So you have to think about what's going to give you that same path through the code. Is it looking at another team member on that same team? Is it looking at a goalie from a different team, somebody with the same last name? You have to think about what your pathways look like through your code. What's going to hit it and what's not going to hit it. Statistically speaking, it's probably you. Not only that, but it is a lot easier generally to put breakpoints in your own code. It's often hard to even figure out where the other code lives sometimes. We can go through a few more strategies. Changing things, create new tests, try and test other pathways to see if there are other things that are broken or what's similar, what's different. Always use a fresh commit before you change a bunch of things. If you don't know what that means, you don't know what version control system means, please look it up. It will save your life. Oftentimes, when I'm at wit's end, Pilot actually will fix it. I will look at Pilot and say, oh wow, why did I not see that? So I highly recommend using Pilot to Flake. Google or your search engine of choice. Make sure that you pull out any function names, anything that's unique to your code, because it will mess up the results. If you're using Python 3, and of course you should be, I find it still useful to put the 3 in the search terms because Python 2 still dominates the top of the stack for searching. And then, most importantly, when you find a solution, make sure that you go through it and you understand what it is that you're looking for. If you understand what you're doing, you're going to be more likely to implement it correctly. And you're going to be more likely to remember it and know what to do the next time it happens. So try not to blindly copy and paste, because you'll get more out of it if you can figure out what it is that they're doing. Don't feel bad about searching. Those of us that have been programming for 10, 20 years are still using Google, I promise you. Debugging is like an onion. There are multiple layers to it, and the more you peel them back, the more likely you're going to start crying at inappropriate times. I like to think of troubleshooting as kind of a game that you're playing, where you're trying to track down something. But sometimes you just get frustrated. Sometimes you just want to throw your computer out the window. And at those times, it's really best to just take a break. Go take a nap, shower, think about something else. Your brain does amazing things when you're not overwhelming it with crap. 20-minute nap is worth 2 hours of banging your head at least. Highly recommend this. If you can't figure out what's going on, try writing everything down. Just the act of writing stuff down can help you realize what it is that you haven't tested, what it is you haven't looked at, the things you haven't done yet. And if you write that down and still don't know what to do, ask for help. We are a great community. We have a Q&A on Slack, and we're willing to help. Thank you. May you win, not the bug.
Does anybody have any questions or things that Maria can answer for you while we're here? Yes.
I know, crazy, right? I'm rebelling.
I don't know how I did, but
Alan's not here.
Alan's not here. We're rebelling.
And then I'll run back across. It'll be fun. It's like calm.
So my question is, I am guilty of never having used PDB. I kind of like the debuggers that are incorporated in the text editor or the IDE. I'm just curious what your thoughts are on that.
I don't actually care what debugger you use, as long as I'm using a debugger. I think probably most of them are, if not using the PDB under the hood, they're at least doing something very similar. So yeah, go for it. It's definitely going to be easier than print all the time.
I turned on. Ooh, this one's on too.
Pull them together.
This
Yes.
stereo. So that is the end of the first half of our evening here. Maria was our first speaker. We will reconvene